The Voice of America presents Forum, the Arts and Sciences in Mid-Century America. Today, as the seventh lecture in the Philosophy of Science series, Forum brings you Professor Willard V. Quine, Edgar Pierce Professor of Philosophy at Harvard University. Professor Quine will speak on necessary truth. Professor Quine graduated summa cum laude in mathematics from Oberlin College and received his doctorate from Harvard University in 2 years, writing his dissertation under Alfred North Whitehead. He began teaching at Harvard in 1936, and in 1948 became a full professor of philosophy and a senior fellow of the Society of Fellows. He has held the chairmanship of both the Philosophy Department and the Society of Fellows. Professor Quine has been a visiting professor at Oxford University, a member of the Institute for Advanced Study at Princeton University, and a fellow of the Center for Advanced Study in the Behavioral Sciences. A member of the American Academy of Arts and Sciences and the British Academy, Professor Quine has served as president of the Association for Symbolic Logic and the Eastern Division of the American Philosophical Society. Among his publications are A System of Logistic, Mathematical Logic, Elementary Logic, From a Logical Point of View, Methods of Logic, and Word and Object. Professor Quine's latest book, Set Theory and Its Logic, is in the process of publication. Professor Quine.
If people thought that very little of what went on in the world happened by necessity, then, surely, they would have little occasion to use the adverb necessarily. But this adverb is in fact frequently heard. So people must think that quite a lot happens by necessity. But if people thought that almost everything that happened at all happened by necessity, then again they would have little occasion to use the adverb necessarily. Mostly it would go without saying. So most people must think that while much of what goes on happens by necessity, much of it also does not. People must have some criterion which they keep using to sort the passing states and events into some that happened with necessity and others that happened without necessity. Otherwise, the adverb necessarily would not be heard so often, or so it would seem. Actually, of course, this is wrong. People have no such criterion. They would be hard put to it to classify any of the passing events outright as necessary or otherwise. For the fact is that the adverb necessarily, as it is most often used, does not mark a present or past event or state outright as necessary. Future ones, yes. Often we represent a future event or state as necessary or not, according as we have or have not an overwhelming reason to expect it. We say, surely she will worry, that is, necessarily. We say, the inhabitants are bound to be hostile, they will necessarily be hostile. We ask, will it break, and are told, not necessarily. I have had to allow in these examples for a certain vernacular twist. Generally, necessarily sounds well after a not, or then, whereas such synonyms as surely and bound to and must are often preferred elsewhere. These necessity idioms are not indeed confined to the future, but when they enter the present and past, they still tend to connote conjecture or inference. Thus, as mayor, he must have enriched himself, necessarily did, for look at his earlier record on the school board. It is paradoxical that these strong words, necessarily and its synonyms, are used mainly where we are less than sure of the facts. What we really know, we usually just affirm without the intensive. Should we, in general, dismiss the adverb necessarily, then, as a mere rhetorical device that people use to cover their uncertainty? No, there is a case for another account. To make it, I shall turn to a more trivial example. Someone says, Surely it has spots. Necessarily it will have spots when told that he is about to be shown a leopard. Now, instead of viewing the adverb necessarily as governing outright the simple prediction of spots, we can understand it as governing implicitly the conditional sentence as a whole. If it is a leopard, it has spots. In attributing a quality of necessity to this whole conditional compound, there is no air of paradox, certainly, nor of rhetorical subterfuge. Something of the same may be done for the other future tense examples. When we say, the inhabitants are bound to be hostile, we are basing our prediction on something, perhaps the recent burning of their granary. So instead of associating the necessity with the inhabitants' hostility outright, we can understand it as attaching to the conditional sentence as a whole. Necessarily, if their granary was lately burned, the inhabitants will be hostile. Again, when we ask, will it break? We mean, if I use it, will it break? So the reassuring answer, not necessarily, can be seen as applying not to the mere breaking, but to the conditional sentence as a whole, as if to say, it is not necessarily true that if you use it, it will break. This treatment works not only for the future tense examples, but also, of course, for the conjectures regarding the present and past. As mayor, he must have enriched himself. We may take the necessity as applying not to this conjectured self-enrichment as such, but to the whole implicit conditional, if when on the school board he did thus and so, then also as mayor he will have enriched himself. In a word, the point is, in all these cases, to seek the necessity not in the separate matters of fact, but in the connections between them. No wonder people would be hard put to it to classify passing events as necessary or otherwise. It is a question, rather, of connections. The next question is, what does it take to qualify a connection as necessary? Here we do well to return again to our trivial example of the leopard. Some leopard is announced, and we expect spots. What is the connection? Clearly, a generality. All leopards have spots. In this, I think, there is the germ of an explanation of the less trivial examples as well. I submit that whenever one says, necessarily, if P, then Q, he has, at least dimly in mind, some fairly dependable generalization under which his particular, if P, then Q, can be subsumed as a case. The leopard example is trivial only because there the relevant generalization is so easily recognized. Why should this newly heralded leopard necessarily have spots? Because they all have spots. Other examples, such as the one about the hostility of the natives, differ from the leopard example only in that the relevant generalization is less clearly hinted in the phrasing of the sentences. Always or usually, when you burn their granary, people turn hostile. The speaker is bound to have had some such generality in mind, and this it is that lends the force to his necessarily when he says of his particular instance that necessarily, if their granary was lately burned, these inhabitants will be hostile. A cautionary remark of a rather subtle kind is called for at this point. We must not suppose that a man is entitled to apply necessarily to an assertion so long merely as he thinks there is some general truth that subsumes it. Thus, suppose I have lost my key. Then immediately we have this trivial generalization. It is true of everyone X without exception that if X is I, X lost his key. Just as on the strength of all leopards having spots, we say that necessarily the upcoming leopard will have spots, so on the strength of this new generalization, we might expect to be able to say that necessarily, I being indeed I lost my key. This line would allow us to attribute necessity to anything, however casual, that we are prepared to affirm at all. I am therefore not suggesting that necessarily, if P, then Q, can be defined to mean there is a true generalization whereof an instance is that if P, then Q. It is a matter rather of the speaker's having antecedently in mind some one actual generalization, whose truth is, in his view, independent of particulars of the case in hand. It is this feeling, I suggest, that would normally prompt the speaker to attach a necessarily to his if P, then Q. He might rather have attached so in particular, if his antecedent generalization had actually been antecedently spoken. What I have done thus far may be summed up as two steps. First, I have argued that the adverb necessarily applies only by ellipsis to particular events or states, and properly rather to whole conditional connections, necessarily if P, then Q. Secondly, I have represented this necessarily in turn, the necessarily of necessarily if P, then Q, as simply an allusion to some presently more or less hinted regularity, all A or B, which subsumes the particular link, if P then Q, as a case. The doctrine that necessity is no more than regularity was expounded by David Hume more than 2 centuries ago. His, indeed, was the battle cry, "There are no necessary connections of matters of fact." He meant, of course, that there are none if necessary is taken as claiming more than generality or regularity. I am not taking it as claiming more. One place in the philosophy of science where the idea of necessity comes in for special attention is in analyzing the so-called disposition terms, such as soluble. To say of a particular lump of stuff that it is soluble in water is, as Rudolf Carnap has stressed, to say more about it than just that whenever it is in water it dissolves, for perhaps this particular lump will never be in water. By default, then, even if the lump is quartz, it would be true that whenever the lump is in water it dissolves, but we cannot on that ground call it soluble in water. For a lump to be soluble, we must be able to say of it that if it were in water, it would dissolve. We need an if-then connection governed by necessity, and by a necessity that goes beyond mere generality over time. To say merely that the lump dissolves at each time that it is in water is too weak. Advances in chemistry eventually redeem the solubility idea, but only in terms of a full-blown theory. We come to understand just what there is about the submicroscopic form and composition of a solid that enables water to dissolve it. Thenceforward, solubility can simply be equated to these explanatory traits. When we say of a lump that it would necessarily dissolve if in water, we can be understood as attributing to the lump those supposedly enumerated details of submicroscopic structure, those explanatory traits with which we are imagining solubility to have been newly equated. A chemist can tell you what they are. I cannot. Surely it will be felt something is wrong here. I seem to be talking intelligibly of solubility, yet by this account it is only the chemist, and neither you nor I, who knows its defining traits. Moreover, the term was already used just as freely and easily before even the chemists had arrived at those explanatory traits. Still, I think we are on the right track. Early and late, solubility has been meant to be some causal agency or mechanism or arrangement in the lump, however little understood. From the start of a scientific attitude anyway, the term has been a sort of a promissory note which one might hope eventually to redeem in terms of an explicit account of the working mechanism. What kind of account of a mechanism might pass as explanatory depends somewhat, of course, upon the general situation in science at the time. Nowadays, in general, one settles for an account in terms of the arrangement and movement of molecules or of smaller particles when finer texture is relevant. And meanwhile, the promissory character of the unredeemed solubility idea was never an obstacle to glib use of the term. For this much one is assured of early and late. Whenever a soluble thing is in water, it does dissolve. We intend in advance that solubility consists precisely in those explanatory traits of structure and composition, however ill-pictured or unpictured at the moment, that do make things dissolve when in water. A disposition term that contrasts, interestingly, with soluble is intelligent. Solubility is the capacity to dissolve in water. Intelligence is the capacity to learn or to solve problems. Whereas chemists have redeemed the solubility idea by uncovering the explanatory traits, the intelligence idea is still as unredeemed as can be. We do not even know whether to seek the explanatory traits in the chemistry of the nerve cells, or in the topology of the nerve net, or in both, or somewhere else. Intelligence today is where solubility was centuries ago. Still, I think it is a promissory note. I do not think we would use the word intelligent if we did not think there was an unidentified but someday identifiable causal agency or mechanism that sets one man above another in learning and in the solving of problems. This account of disposition terms is not to deny that X is soluble means that if X were in water, it would dissolve. This equation is still good. Accordingly, what I proceeded to say about disposition terms serves, insofar as it illuminates them, to illuminate also the subjunctive conditional idiom itself. If X were treated thus and so, it would do such and such. This even is the general idiom for attributing dispositions. Whether a single word like soluble or intelligent happens also to exist for the disposition is immaterial. In general, when we say, if X were treated thus and so, it would do such and such, we are attributing to X some theoretical explanatory trait or cluster of traits. Typically, these would be traits of microscopic structure or substance. Sometimes they are analytically describable in all explicitness by specialists, if not by us, as in the case of solubility. Sometimes they are envisioned only as someday describable. Such a conditional sentence may or may not flaunt the adverb necessarily. In any event, the subjunctive form connotes it. Now altogether, the uses of the necessary conditional are varied and unsystematic. But this use, for imputing dispositions, is an important one among them. Another use was seen in the example of the leopard and the spots, which so neatly fitted Hume's theory of necessity as generality. Now the conditional as used to impute dispositions may be said, in a sense, to come under Hume's theory too. If this lump were in water, it would dissolve. Where is the underlying generality? It is in the explanatory trait, which is solubility itself. Everything that has that subtle trait of microstructure dissolves when in water. In each of the necessity constructions, even the leopard example, the speaker has some one line of generalization in mind and not another. In the leopard example, we easily guess. It is a question of all leopards. In the example of the inhabitants being hostile, we could not guess, but had to be told that the speaker was generalizing over peoples whose granaries were burned. And in the necessity constructions that impute dispositions, the generality lies along some known or posited explanatory trait. Thus, the necessity constructions that impute dispositions do not depart from the Humean pattern. They turn still on generality, But they turn on theory, too, precisely because they fix upon explanatory traits for their domains of generality. The uses of necessarily that we have been considering up to now might loosely be spoken of as physical or natural necessity, as against the narrower notion of logical or mathematical necessity. A truth that might be cited rather under this latter category is that momentum is proportional to velocity. This might be said to be logically or mathematically necessary on the ground that the word momentum is itself defined simply as short for mass times velocity. But now imagine a physicist with some unexpected experimental findings to provide for. They conflict with his physical theory. There is no specific point in his theory that they conflict with, for observations do not conflict with theoretical statements one by one, but they show that the theory taken conjunctively is false and must be changed at one point or another to inactivate the false prediction. And now suppose the physicist hits upon a particularly neat repair which involves revising slightly the law that momentum is proportional to velocity. He makes momentum proportional instead to, say, velocity divided by 1 minus the reciprocal of the square of the speed of light, which deviates negligibly for most purposes. Will his colleagues protest that he is flying in the face of logical necessity? Will they protest that he is departing from the definition of momentum and so depriving his theory of meaning? Will they protest that he is redefining momentum and so merely playing with words? I think they will do none of these things. His modification of the proportionality of momentum to velocity will strike them in no other way than a modification of any other time-honored proposition of physics might strike them. And this, I feel, is as it should be. In supposing the contrary, we unduly exalt the act of definition. There are two ways in which we may learn a theoretical term: through context, by learning a network of laws in which the term occurs, and through definition, by learning what phrase to substitute the term for. But this difference may best be seen merely as a difference in the history of one's learning, and not as making for an enduring difference in status between the variously interlocking laws of the theory itself. Thus, I am inclined to dismiss the idea that a special category of necessity, the logical or mathematical, is represented by the law that momentum is proportional to velocity. And my reason is that I attach no relevance to the status of definition. The statement that momentum is proportional to velocity was supposed to be mathematically necessary because that definition, when expanded, turned the statement into a mathematical triviality. It may be well, then, if my skepticism is over the definition, to forget the definition and turn our attention to the mathematical triviality itself. Mass times velocity is proportional to velocity. How is this for a case of mathematical necessity? Admirable, certainly. But is even this necessity somehow different in kind from what can be attributed to ordinary truths of physical theory or other natural sciences? A long-standing doctrine says that it is, and I should like to conclude my remarks by questioning that doctrine. It depends, I think, upon a terminological boundary between physics and mathematics. Thus, let us begin by supposing that we have somehow drawn a boundary across the face of physics, at some points perhaps quite arbitrary, so as to separate a more speculative and theoretical half of physics from a more experimental and empirical half. Let us call the one side theoretical physics and the other experimental physics. Now it strikes me that the contrasts that people are prone to draw between pure mathematics, such as arithmetic, on the one hand, and physics on the other, can be drawn just as well between theoretical physics and experimental physics. People say that physics is about the world, that it has empirical content, while arithmetic and other parts of pure mathematics do not. They grant that these mathematical disciplines have their motivation and their utility in the applications to physics and other natural sciences, but they call this a matter only of motivation and application, not content. Now, why can we not say precisely this of theoretical physics in relation to experimental? Certainly it has its motivation and utility in applications to experimental physics. But why not say that this again is a matter only of motivation and not of content? I think our not saying this is an accident of nomenclature. Theoretical and experimental physics are both called physics. We see them as part of a single systematic enterprise connecting ultimately with observation. Pure mathematics, on the other hand, partly because of its additional utility in natural sciences other than physics, is segregated in name. So we do not see it as just a further part of a broader systematic enterprise, still connecting ultimately with the observations of experimental physics and other natural sciences. Boundaries between disciplines are useful for deans and librarians, but let us not overestimate them, the boundaries. When we abstract from them, we see all of science, physics, biology, economics, mathematics, logic, and the rest, as a single sprawling system, loosely connected in some portions, but disconnected nowhere. Parts of it, logic, arithmetic, game theory, theoretical parts of physics, are farther from the observational or experimental edge than other parts. But the overall system, with all its parts, derives its aggregate empirical content from that edge. And the theoretical parts are good only as they contribute in their varying degrees of indirectness to the systematizing of that content. In principle, therefore, I see no higher or more austere necessity than natural necessity. And in natural necessity, or our attributions of it, I see only Hume's regularities bolstered here and there by an explanatory trait or the promise of it.
You have heard Professor Willard V. Quine of Harvard University's Department of Philosophy speak on necessary truth. Professor Quine's talk was the 7th in a series of lectures on the philosophy of science, planned and coordinated by Professor Sidney Morgenbesser of Columbia University. Next week, Professor Patrick Suppes of Stanford University will consider the definition of a scientific theory. Copies of the lectures in the Philosophy of Science series may be obtained after the entire series has been broadcast by writing to the Forum Editor, Voice of America, Washington 25, D.C. This is William Reynolds inviting you to join us again next week at this time, when the Voice of America will present Forum, the Arts and Sciences in Mid-Century America.